All right, today we are going to talk about the converse of the Pythagorean theorem. Who remembers what's happening tomorrow?
Quiz.
We have a quiz over 7.1 and 7.2 tomorrow. Quiz tomorrow. It's on the assignment guide. All right, today we are going to use the converse of the Pythagorean theorem to determine, bless you, if a triangle is a right triangle. Before we do that, we are looking to find x on warm-up number 1. So we will just use the Pythagorean theorem. Bless you. Ooh. When we use the Pythagorean theorem, remember the equation formula associated with it is
A squared plus B squared equals C.
very good. A squared plus B squared equals C squared. So on this problem, what do you want to plug in for A?
2,
Sure. What about B?
5,
Sounds good. And C has to be X. You could have swapped the 2 and the 5, A and B, for the legs. The hypotenuse has to be the side across from the right angle, or the longest side. 2 squared, 5 squared. To get X alone. Oh, sorry. Add them first, yes. 4 plus 25. Okay, then to get X alone, square root. Will that radical simplify? No, it sure won't. So you can leave it as X equals the square root of 29. All right, on number 2, we are simplifying an algebraic expression. 5 radical 3, the whole thing gets squared. When you square something, you are multiplying it by itself. So if you needed to see this expanded, you could write 5 root 3 times 5 root 3. Things that are outside of the radical get multiplied together. So 5 times 5 is, things under the radical get multiplied together. So 3 times 3 is, the square root of 9 is really 25 times 3 is 75. Now, if you kind of knew 5 squared is 25, radical 3 squared is 3, you don't necessarily need to show me all of that. But in case you need to see it written out expanded for it to make sense, there it is. Questions, concerns, or need more time on the warm-ups? Kobe? All right. The converse of the Pythagorean theorem states, if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other 2 sides, then the triangle is a right triangle. So this is saying that if it's true that a squared plus b squared equals c squared, then we would know triangle ABC is a right triangle. So we're just going backwards. Remember, the converse switches the hypothesis and the conclusion. This time we don't necessarily refer to C as the hypotenuse yet because we haven't shown or proven that this is a right triangle. If it's not a right triangle, then you don't have a hypotenuse. We do, however, have a longest side. Questions, concerns, or need more time before we do an example or two? Okay. tell whether the given triangle is a right triangle, verify. So that means we have to show some work. We can't just say, yeah, it looks like they have a right angle there, and put a right angle box and call it a day. We actually have to use the converse of the Pythagorean theorem. In order to do that, we need to know which side is the longest side. Now, for letter B, that's easy. For letter A, it might not be as clear because you might not know off the top of your head the decimal approximation of 3 root 34. So before you get started, you might want to type in 3 root 34 just to get a decimal approximation to know where that compares to the other lengths. Anybody get it?
17.49.
Okay, so this is approximately 17.49 or 17.5. Really, you could even just know that it's approximately 17, and that would tell you that that is your longest side. Does that make sense? When we do the problem, we're not going to actually use the decimal, but we need to know which side is the longest, bless you, in order to do this. So we are going to take a squared plus b squared, and we are going to compare it to c squared. So sometimes I just put a little box there because I don't know how they're going to compare yet. So I don't want to put an equal sign if it doesn't end up being true. Does that make sense? Okay. So what do you want to plug in for A? Okay, so 9 squared plus B, 15 squared. Okay, again, leave it blank or write a little box there or something. In for C. Remember, we're not going to use the decimal. We need to use the actual side, which is 3 root 34. Okay, the only reason I even got the decimal was to know which side was the longest. All right, 9 squared is 15 squared. What about 3 root 34 squared? It should be the same as taking 9 times 34. 306? Okay. So if you're putting this in a calculator, if you're typing this in 3 square root 34, usually your calculator opens up parentheses and you would have to like close them. You would also have to put parentheses or brackets around the whole thing. Otherwise, it's just going to square the square root of 34 and then multiply it by 3. So if you're doing this in a calculator, make sure you're typing it in carefully. All right, to finish this off, we need to add 81 and 225. What do we get? 306. How does 306 compare to 306? They are equal, so is it a right triangle? Yes. So yes, it's a right triangle. Sure.
So you know how like for the warm up we did what we're gonna do was 3 in a radical and we multiplied
Yep.
it by 2. So why don't we do the 34 times 34?
So you can do that. So you could do 3 times 3 would be 9 times, and then underneath the radical you could take 34 times 34. It would be a rather large-ish number. But then you would end up with just a 34. Because this is squared, 34 times 34. So,
Okay.
does that make sense? Okay. Other questions? All right. On letter B, this one is a little quicker to get started. What do you want to plug in for A? Okay. B. And what has to go in for C? Okay, again, I either leave it blank or put a little box. I don't know that they're equal or not equal yet. 24 squared. Oop, wrong pen. 576. 22 squared. 404. 26 squared. 676. Okay, are these going to end up being equal? No, these are not equal, so I'm not even going to worry about the sum. You can put it if you want. It would be, what, 980? 980. Yes, ma'am?
Yeah, that's
Yeah, it was
484? Oh, sorry. I just misheard. Erase, so it would not be 980. It would be bigger than that. 484. What would it be? 1060. Okay. Either way, not equal. Yes, ma'am.
Did you count off if we put an equal sign when we were doing like the math?
I wouldn't necessarily mark it off. I would just make sure you're not going to get yourself confused because we're about to add in more knowledge that is similar to this using inequality symbols. Okay, so I wouldn't put an equal sign unless you know they're equal. That's just good mathematical practices. So if these are not equal, then we would say that this is right triangle or not? Not a right triangle. Not right, or not a right triangle. Questions, concerns? Need more time? Okay. We have more triangle Pythagorean theorem converse related theorems. If c squared is less than a squared plus b squared, then the triangle is acute. If c squared is greater than a squared plus b squared, then the triangle is obtuse. Okay, so this is why I never put an equal sign, that I usually put that little box. You might also notice that they've flipped it around a little bit. They put c squared on the left side, or did c squared first, because it's easy to associate a less than symbol with acute and a greater than symbol with obtuse. Does that make sense? Small, acute, bigger, obtuse. So you might want to get in the habit of c squared going on the left side when you're trying to decide what type of triangle it is. Again, if it ends up being equal, we still know that it would be a right triangle. So it might be helpful to put c squared on the left side when we're doing these. Are we ready to keep going? Okay, here we go. Can segments with the lengths 11.2 inches, 6.5 inches, and 7.1 inches form a triangle? If so, classify the triangle as acute, right, or obtuse. So, step 1, use the triangle inequality theorem to make sure the segments can form a triangle. Does anybody remember the triangle inequality theorem? It had to do with adding sides together. If you add any two sides of a triangle, that sum should always be bigger than the third side. Does this sound familiar at all? It should. Okay, if you take two sides and add them up, it should be bigger than the third side. Now, we don't need to check 11.2 plus 6.5 because on its own, 11.2 is bigger than 7.1. So you don't necessarily need to check all of them. What's the important one to check on this? Good, we got to check that the smaller two add up to a number bigger than the largest side. So if we take 6.5 plus 7.1, what do we get? 13.6. And 13.6 is bigger than 11.2. So it can form a triangle. So forms a triangle. You don't necessarily need to state that, but you can if you want to. It forms a triangle. So now we have to worry about classifying it. Do we have questions about deciding if it can form a triangle or not? Okay, if you get that it does not form a triangle, then you cannot classify it. So if the answer is no, doesn't form a triangle, you would not move on to the second step. But it does, so we will. Let's put c squared on the left like they did on the notes just before this. What side am I plugging in for c? Okay, 11.2 squared. Again, I use a blank box because I don't know how it compares yet. What am I plugging in for a? Sure, 6.5 for a squared plus for b, 7.1 squared. Okay, 11.2 squared. Okay, I would not be rounding these at any time, even though they're not super pretty. Just be going with it. 6.5 squared. 42.25 and 7.1 squared. Okay, so it's probably pretty clear right now that this is not going to be a right triangle, right? Okay, the decimals on the ends don't add up for it to be a right triangle. So let's figure out if it's acute or obtuse. If I add 42.25 to 58.41, what do I get? 92.26? 66. Okay, like that? Okay. All right, so how do these compare? C squared is greater than, which makes this obtuse. Okay, do we see why I'm not a fan of using an equal sign? Okay, we'll use a little blank space or a box or something. Questions on example 2? All right. If the segment lengths form a triangle, would it be acute, obtuse, or right? So first, we don't even necessarily need to write it out, but you should be doing a mental check. Will these form a triangle?
Yes.
What mental math should you be doing to check? 10 plus 11 is greater than 14. 10 plus 11 would give us 21. That's bigger than 14, so we can proceed on to step 2. On the left side, we should be putting our c squared, which in this case is 14 squared. Comparing that to 10 squared plus 11 squared. 14 squared is? Okay, 10 squared. 11 squared. Okay, obviously not going to be a right triangle, but we can classify it otherwise. If I add 100 and 121, 221. So in this case, c squared is smaller, less than, so this is acute. All right, on 3B, before we get started, it might be nice to have a decimal approximation for 5 root 13. What is it? 18 point something, right? 0, 2, goes on and on. We're not actually going to use that number in our problem, but we would want to check to make sure that 10 plus 15 is greater than that, is it? Yes, Taylor?
What do I do if my calculator won't do that?
It will. So if you type it in, and then this button will give you a decimal.
Hold on, how you do it?
Calculator question?
Yeah.
So on this calculator, I would probably do the root part first. So square root of that, and then times the 8, or not times the 8, times the 5. So I would do, find the square root, multiply by the number out in front. Okay. All right, so when we do this, we check to make sure the sum of the smaller two is bigger. It is. 25 is bigger than 18 point anything. So then we move on. What are we plugging in for C?
5 root 13.
Okay, so 5 root 13. That whole thing gets squared compared to 10 squared plus 15 squared. What is 5 root 13 squared?
325.
We agree with 325? That seems about right. 25 times 13 compared to 10 squared. 15 squared.
225.
When we add 100 and 225,
325.
so what symbol belongs in my little box? Equals, which means this is
Right.
a right triangle. Other questions, concerns? Nothing? Okay, your homework is on your assignment guide. Should match what's on the board. It does.